impressed to see such a large turnout. I have to confess I was not in the area at the time that Agnes occurred. I was actually just finishing my first year in college in New England, but I later became a graduate student at Johns Hopkins, and my advisor, Red Woolman, seen in this picture, was someone who studied floods. In fact, this picture was taken along the Jones Falls in the aftermath of Hurricane Agnes. The stool he's sitting on was actually pulled out of a tree. And Red's had generations of devoted students. Unfortunately, we lost him a couple of years ago, so I just want to dedicate this to him and his abiding interest in rivers and floods. So I want to make a few key points. I'm not going to actually read all of this. But floods are predictable in the sense that we know they're going to happen. We just don't know when they're going to happen. We know about how often they're likely to happen, but there's a lot of uncertainty associated with those estimates. So for that reason, there's also a lot of uncertainty about exactly which properties are at risk. But one thing we do know is that no matter how you do the accounting, the Patapsco River Valley is steep and narrow, it's prone to flooding. It has been that way forever, and it will continue to be that way. Now, there are a variety of different kinds of floods that affect our landscape. Some of them concern things that go on along the coast, such as Hurricane Isabel, which of course brought storm surge flooding to our region in 2003, and extratropical cyclones such as the Ash Wednesday storm in 1962. Our concern here today is large floods that occur in inland regions that are brought by tremendous amounts of rain. And although there are a variety of different kinds of major storms, of course Agnes is one particular type of storm, a tropical cyclone that actually transitioned into an extratropical storm as it moved inland and then up to the north. So the main point, which I don't really need to explain to all of you who spend so much time along with the Patapsco, is that the narrower and steeper the valley, the deeper and more powerful the force of the water is going to be. But the nature of flooding that occurs in this landscape is that the valley itself is narrow and steep because of the particular part of our regional landscape where it's located. That is what we would refer to as the fall zone. So here's a regional physiographic map showing the Chesapeake Bay region, the coastal plain, the Piedmont, the rolling upland landscape in which the Patapsco Valley is found, and then of course the Appalachian province is a little bit further out to the west. And as the Patapsco works its way down through the Piedmont, it enters the fall zone and forms this deep, narrow gorge, which accounts for the very steep gradients. You've got big boulders, you've got high velocities when you do get a lot of flooding, and we have perfect conditions in this region also for giving us very intense rainfall. Now, this is the Patapsco watershed. This is the gauge operated by the U.S. Geological Survey at Hollowfield, a few miles upstream of Ellicott City, which is right down here. And this is Liberty Dam. So it turns out that about 60% of the watershed actually is upstream of Liberty Dam, which was closed in the mid-1950s. So without Liberty Dam, Agnes would have been an even bigger flood because most of the flood water had to come either through this dam or else from the remaining part of the watershed. This shows you a Google Maps view of the terrain illustrating the very steep and incised topography along the river valley. And just for location's sake, because I believe when Bob Miller shows his video, you're going to see references to places like Woodstock and Daniels. This here is where the USGS gauge is located. Here is, of course, Ellicott City, and Ilchester is down here. And this is a shaded relief image of the topography illustrating just how steep and narrow this valley is in the vicinity of Ellicott City as it is along much of the rest of the valley. This is taken from LiDAR, which is a laser form of radar. It gives us very detailed topographic information. And you can see just how steep and narrow that valley really is. And of course, if you look down valley, this was taken from a short distance upstream of Ellicott City, you can see the size of the boulders in the channel. That's pretty typical. This is actually flood debris left behind by Tropical Storm Lee back last September. So Agnes was a tropical cyclone that made its way up from the Gulf, came inland on the panhandle of Florida, then made its way up through the southeast, went offshore to the Outer Banks, turned around and came back inland into New York. But while it did that, it slowed down and decayed from being a tropical storm It combined with another weather system and became what we call an extratropical cyclone. It slowed down. It did not bring very heavy winds or a lot of storm surge. What it did do was to drop tremendous amounts of rainfall over a very large region. And so it's known as the flood of record, particularly in Pennsylvania, but also large parts of our area here. This is a map showing the distribution of rainfall, and you can see that the blue area here had 15 inches or more of rain, and that's over a pretty significant portion of central Pennsylvania, parts of southern New York, and parts of Maryland and Virginia. The heaviest rainfall, as it says here, occurred a good distance away from where the tropical storm actually came inland, and the moisture that dropped over this landscape to give us all that rain was enhanced by the steep slopes in the Appalachians here. As the air comes inland and is forced upslope, it causes the moisture to fall out as rain, and the storm got stalled and hung out over this area for several days in a row. So that's largely responsible for the amount of rain we got. The maximum rainfall was 19 inches in Schuylkill County, Pennsylvania. In terms of the damage that was done, it was in fact the most costly natural disaster in United States history up until that point. Of course, we've had quite a few since then, and you can expect to see many more. Maryland actually was the number 4 state in terms of the amount of damage, number 3 in terms of the number of fatalities, but Maryland had about $110 million worth of damage, whereas Pennsylvania had more than 20 times that much, more than $2 billion. And the total amount of losses were more than $3 billion, which I believe in today's dollars is probably 4 or 5 times that amount. And these are just some pictures from various places in the flood. They're probably mostly from Pennsylvania and New York. You'll see pictures from local areas when Bob shows his video. Now, I just want to point out that although Agnes is, of course, the storm we're here to remember, you're not unique in the sense of being a storm that produces huge amounts of rain. So I'm just going to run through a bunch of these slides very quickly to illustrate we've had a whole bunch of storms. This one, Eloise, was only 3 years later, and it actually had maximum rainfall close to 15 inches, actually in some of the same areas. But then a few years after that, we had Hurricane David, which caused intense flooding in a few smaller areas, maximum rainfall more than 15 inches. Then we had Floyd in 1999, which caused maximum 24 inches of rain in North Carolina, but you can see a streak of heavy rain that came up through central Maryland and then on up through New Jersey and New York. We see Isabel, which didn't bring much rain to us here, but it drove water up and caused a lot of coastal flooding, but it did in fact bring more than 20 inches of rain in one spot in Virginia. This did not cause as much inland flooding elsewhere simply because it raced through the area so rapidly. And then, of course, last fall we had Hurricane Irene, maximum of almost 16 inches of rain, worked its way up through the coast, and then up into New England. It did a lot of damage up in this region here. And then Tropical Storm Lee, just about a week later, which started on the Gulf Coast, did much the same as what Agnes did, except it didn't go offshore, and turned into an extratropical system and dropped tremendous amounts of rain through here. And although in our local area it was not nearly as big a flood, the flood on the Patapsco was less than a quarter of what it was in Agnes. In some areas it was actually close to or even bigger than Agnes. And that also brought a maximum of more than 20 inches of rain in Colonial Beach, Virginia. This is a video, and I'm using it. This shows you Lee, but it gives you an idea of what happened during Agnes as well. So here you see the tropical cyclone making landfall, and it combines with this frontal system, and as it works its way north, you see these bands of clouds carrying intense precipitation all the way up through this region of the central mid-Atlantic. So these kinds of tropical cyclones that go through what we call an extratropical transition, because of the nature of how these atmospheric patterns interact, again, they slow down and then they have the capacity to drop just enormous amounts of rainfall over our landscape. And those of you who are in Ellicott City will remember the Tiber River overflowed its banks, and you had water running down Main Street. But Agnes, of course, is still the flood of record, as we've already said, not only in central Maryland, but also a bit further to the north. This shows you the flood marks next to the Railroad Museum down along the river. And you'll notice that Eloise was 5.5 feet lower than Agnes just 3 years later. The flood of record, of course, we don't know exactly how large it was in terms of total flow, because we didn't have a record at that time. But there is an historical record, and I forget the name of the book, which I think you've got a few copies of, but there's a book that was published, I think the speaker last year was the author of that book. There's a whole chapter about floods, and the 1868 flood is one of the more prominent floods in the record, 7 feet higher than Agnes. Here's the sign, right up at the top of the fence, over here. Now think about how large an area is underwater when the water was that high. Of course, there was no Liberty Reservoir at the time that flood occurred. It's quite possible that Agnes would have been much bigger if there had been no dam upstream as well. Nevertheless, this is the largest flood in the record that we know of. So this is a representation of what we call the annual flood series. What I've done is to plot by year the magnitude in terms of the volume of flow in cubic feet per second for each of the largest floods over the period since the gauge got going in about 1945. There's one older flood in 1933 that was about 36,000 cubic feet per second. But Agnes is about 81,000 cubic feet per second, almost twice what Eloise was 3 years later. The old, and Lee, of course, is down here. The 1868 flood, we don't really know where it is. It's somewhere up here off the screen. Now, we can take this kind of data set and do an analysis, do what we call flood frequency analysis, to try to figure out about how often we might expect to see a flood of this magnitude. And so I've done that, and that's what you showed on the next slide. And I simply plotted up all the individual events as dots, and then the projected flood frequency curve is shown here as the black line. And when we take the Agnes flood and estimate how often you might expect to see a flood of that magnitude, it works out to somewhere about 135 years. Having said that, notice these are the upper and lower what we call confidence intervals. This means basically that this is an estimate, but the error bars are enormously large. Keep that in mind when you look at questions about the risk of a property being flooded, because they're just using this line and projecting the area that will be underwater. They're not accounting for the error that may be associated with any kind of flood frequency analysis. So if you look at, say, the 100-year flood, it could be anywhere between about 25 or 30,000 cubic feet per second and about 150 to 200,000 cubic feet per second. I actually did flood frequency analyses for a number of other stream gauges with long records in the area, and they range from anywhere from around 80 years on Little Falls at Blue Mount to on the order of about 600 years on Western Run in northern Baltimore County. And I did it for the Susquehanna River in Harrisburg, and that came out to more than a 600-year flood as well. So this was a huge flood by any standard, and there were many, many places that had flood recurrence or return periods that were longer than 100 years, in many cases more than 200 years. So I just want to take a moment to say something about this notion of the 100-year flood. The 100-year flood does not happen every 100 years on a schedule. It's a common misconception that can lead to a lot of trouble. You can get it twice in 1 year, or you may not get it for more than 100 years. How many of you are familiar with FEMA? Right. How many of you have heard of flood insurance rate maps? Okay? If you live in a flood-prone area, or if you actually are in downtown Ellicott City, you're probably familiar with that. So they use the kind of analysis I just showed in order to project the area that will be underwater when the flood reaches a certain size, and they map this thing called the flood hazard area, which is the area that will be inundated by a flood event that has a 1% chance of happening in any given year. And that's called the base flood or the 100-year flood. That map does not indicate the range of uncertainty. It would be almost impossible to draw a map that does, and yet the map is a legal document and it has legal standing. What they will do, of course, is to project the area that would be underwater when the water gets up to a given level, and they'll project that area onto a map, and I'll show you the Ellicott City area in a moment. But I have a little question to answer. Who owns the floodplain? It's the river. And those who think they own that floodplain sometimes turn out to be seriously in error when the river comes and claims its property. Luckily, it doesn't do so that often, but we have to be prepared for that eventuality if we actually are living and working in floodplain. So back again to these three floods, which you could use as benchmarks to try to get an idea of what area might be flood prone. And I took the flood insurance rate maps. Because we're in two different counties, I tried to overlay the one for Howard County with the one for Baltimore County to show that there's an area basically along Main Street that's within the 100-year flood zone, and then a fairly broad area right down near the bridge by Main Street and Frederick Road. But then the valley gets narrower and steep, and so upstream and downstream, the flood-prone area is relatively small, which means the velocity is going to be high and the depths will be great. So this just shows you that same area, and you can see the size of the boulders in the channel, the amount of debris that gets moved by a flood, even the size of what we had last fall with Lee. And by the way, the 1868 flood was at about this level. Agnes was at about this level. Okay? And this is just looking down valley at part of the area that would be expected to be underwater if we got a recurrence, or if we had something like a 100-year flood. Okay. This is a Google Earth view of Main Street and the Tapsco River and the Baltimore County side and Oella. Just to give you some benchmarks, here's probably stop over here, and I don't remember all the names of the businesses, but Bob Miller, in his video, I think is going to refer to some of these locations, which is why I use this as what I think is my last slide. Yes. Okay, so I'm going to, Bob, I don't know if you want to come up here, but I'm going to go ahead and start your video.
Yeah, you don't have to start with mine.